So in this context, the role of the production manager is to make sure that the production process is going efficiently. Produce in terms of the simple graph, we want to produce output on the production function. Just because we can draw the production function does not mean that we are producing on it. Okay, remember the total product curve is the maximum output that we can squeeze out of our inputs. Okay, and then the other role is to use the right mix of inputs to maximize profits. Okay, the textbook goes into some ISO quant and ISO cost analysis. And then if you were an economics major, you remember this from the intermediate microeconomics course. Okay, well, that's not a level of economics that I want to cover in managerial economics at the MBA level. So we're skipping that. And so we'll focus our attention on the right mix of inputs in the short run to how much labor to employ. Okay, so let's think about the first role of the manager. Okay, we want to produce output on the production function. And so here is the graph from the window manufacturer. We've got the total product curve as output goes from 0 to 11. Okay, and I've added a couple lines here just as an example, the labor input of 5. Okay, so the efficient amount of production when the labor input is 5 is 90. That's the most output and the most windows that we can produce. Okay, but I'm sure you can imagine a situation where something less than 90 is produced. So here's an example, maybe 70 windows are produced. Okay, so we're operating inside the total product curve or below the total product curve. And so that's inefficient. So our average product is 18 windows per worker. And the inefficient measure of productivity would be an average of 14 windows per worker. So the role of the manager is to try to align incentives that leads to maximum worker effort. Okay, so if you can encourage workers to do the best they can, you can move this red dot up to the total product curve. Okay, and then the second role for managers is to use the right mix of inputs. Okay, so in the short run, to maximize profits when either labor or capital can vary in the short run, but not both. Okay, the manager will hire labor. Let's say capital is fixed, and the manager would hire labor until what's known as the value of the marginal product of labor equals the wage rate. Okay, and this value of the marginal product of labor, this is the benefit of hiring labor, the marginal benefit of hiring labor. And then if labor is hired in a competitive market where the business firm cannot influence the wage rate, if the business firm tries to hire workers below the market wage, no one applies. Okay, that's the assumption we're making. So in that case, the wage rate is the marginal cost of hiring workers. So just applying the first equimarginal principle that we talked about in chapter 1, the business firm would want to hire workers until the marginal benefit is equal to the marginal cost. Okay, and that rule extends to capital. Let's say in the short run, the amount of labor we can hire is fixed for some reason. There might be some union contract that constrains our labor market decisions. Then if you can rent or use different levels of capital, then you would want to hire capital until the value of the marginal product of capital equals the rental rate. Okay, until the marginal benefit of capital is equal to the marginal cost of capital. Okay, then in both of these situations, the value of the marginal product of labor, or the value of the marginal product of the input, is going to be equal to the market price times the marginal product of labor. Okay, so let's think about that. The marginal product of labor is the change in output generated by a change in the input. Okay, so if we monetize the change in output by the market price, then that gives us a monetary value, value of output, and that's the marginal benefit of hiring workers. Okay, so since the value of the marginal product is the value of the output produced by the last unit of the input, okay, and think back to the law of diminishing returns, okay, the marginal product of an additional unit of output will decline with additional units of that output. Okay, so in order to maximize profits, we want to use the input level to the point where the marginal benefit equals marginal cost. Okay, so the role of the manager is to continue to employ labor up until the point where the value of the marginal product of labor is equal to the wage rate, and that will be in the range of diminishing marginal product. Okay, so let's see how that works with the window production example. Okay, so here I've graphed the labor demand problem, okay, in the range of labor from 0 to 7. Okay, so now I'm dismissing the stage 3 of the production process. Okay, so the value of the marginal product, I've graphed it now. I've multiplied the marginal product of labor by the price of 12. Okay, you can see that as long as the value of the marginal product of labor is greater than the wage rate, which in this question is $60, then our revenues are greater, our additional revenues are greater than our additional cost. So since profit is equal to revenue minus cost, if revenues are rising faster than costs are rising, then our profits are increasing. Okay, so the value of the marginal product curve is the marginal benefit curve. As long as marginal benefits exceed marginal cost, then we should employ more workers. And then when we go, so that's going to be 6 workers. Okay, you can see the 7th worker, if we've been doing this great thing, hiring workers, and our profits have been going up. But then we hire a 7th worker, and the 7th worker's additional output is lower than the 6 workers. And that thing has been diminishing marginal returns has been happening since 3, but profits have still been increasing. But now the additional revenue generated by the 7th worker is less than the additional cost of hiring them. Okay, so the value of the marginal product of labor for the 7th worker is less than 60, and so our profits go down when we hire the 7th worker, and so the effective production manager would recognize that and eventually reduce workers from 7 to 6. And it turns out that the value of the marginal product of labor curve is the labor demand curve. Okay, so imagine what happens if the wage rate goes up to 200. So that's a big wage increase, but it's a useful example for our purposes. So here I've graphed, so the dotted red line, the dotted horizontal line is the wage rate at 60, and that has increased to 200, which is the solid red line, wage of 20. wage of 200. Okay, so when the wage rate goes up, all of a sudden, at 6 workers, the marginal benefit of hiring workers is 60, but the marginal cost is 200. So we just lost money on the 6th worker. So we scale back to 5 workers. Okay, and we are still losing money on the 5th worker. The marginal benefit of the 5th worker is less than their cost. So we scale back to 4 workers where the marginal benefit is $240, which is greater than 200, which means that we've maximized our profit at 4 workers. And we'd like to increase the number of workers, but in this example, the number of workers is lumpy. It's discrete. We can't hire a fraction of a worker, although we might start thinking about hiring someone part-time. Okay, so 4, so when the price rises, the price of this good rises from 60 to 200, we reduce our quantity demanded. In this case, the good is labor, the service is labor. So as price goes up, quantity demanded goes down. And you can imagine a situation where price falls from 200 back to 60, and we'd hire those 2 workers back. So as price goes down, the quantity demanded for labor increases. So along the value of the marginal product of labor curve, the wage and the quantity demanded of labor are inversely related. And so we've developed a relationship for the business firm's demand for labor.